Welcome to Honors Geometry Lesson 10.2, Arc Measures, where we talk about what an arc is, what its measure is, and this is going to have repercussions from Chapter 1 when, we talked about congruent segments and congruent angles and the length of a segment and the measure of an angle and the angle addition postulate, the segment addition postulate, but this time it's all going to be doing with arcs. So let's go ahead and learn about arcs. Okay, central angle is defined as an angle whose vertex is the center, O, and whose sides are radii, OB and OD. So angle BOD, angle BOD, is a central angle. A minor arc is defined as part of a circle whose measure is less than 180 degrees and is also equal to the measure of its related central angle. So you are going to use the endpoints to name a minor arc. So we're talking about arc BD, and this little m stands for measure. So the measure of the measure of arc BD, the measure of this arc, is equal to the measure of angle BOD. So a minor arc equals the measure of its related central angle. So those are minor arcs. Oops, missed one. A major arc is defined as part of a circle whose measure is between 180 and 360. This number can be found by computing 360 minus its related minor arc. Okay, and you are going to use the endpoints and any point between it to name a major arc or a semicircle. So, arc MLN is a major arc. Okay, MLN, just to show you, start at M, go through L to get to N. That's major arc MLN. And to find the measure of that arc, you're going to take the measure of arc MN, that minor arc, and subtract that from 360. Okay? A semicircle is defined as half of a circle whose measure equals 180. So if you look at this diameter LN, segment LN, that cuts the circle into two semicircles. And the name of those semicircles are arc LMN. That would be this arc here, LMN. That arc is a semicircle. And arc LXN. That also is a semicircle. And make sure that you use 3 points to name semicircles or major arcs. Moving right along. Adjacent arcs are defined as arcs on the same circle that share a common endpoint. Arc FG and arc GH are adjacent arcs. They're right next to each other, FG and GH. We're not sure if they're congruent the way they're drawn. They may be congruent. Congruent arcs are defined as arcs that have the same measure, that are on the same circle, or on congruent circles. So in order for arcs to be congruent, they have to have the same measure, but they also have to be on the same circle or on congruent circles. Congruent circles are defined as two circles that have the same radius. So circle O and circle A are congruent to each other because they both have the same radius length. So, did I not tell you that was going to be a lot like Chapter 1? Yeah, definitely. I mean, look at the minor arc. Okay, that's kind of like a acute angle, kinda. And then major arc is kind of like an obtuse angle, but it's an arc instead. And a semicircle kind of like a right angle, except for everything is twice as big. And that leads us to the last one that again looks a lot like chapter 1 with segment addition postulate or angle addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So the measure of arc RT equals the measure of arc RS plus the measure of arc ST. And just like that, we are done with section 10.2. This does conclude lesson 10.2, honest geometry, arc measurement.